My dear students, in this video, in the topic linear programming for CBSE 12th standard students, I am going to solve one problem called a transportation problem. This transportation problem states that an oil company has two depots A and B of capacity of oils, A having 7,000 liters of oil and capacity of the depot B is 4,000 liters of oil. From these two depots, the oil is transported to three different pumping stations D, E and F. The requirements of the pumping stations are 5,000 liters, 3,000 liters and 3,500 liters respectively. And the cost of transportation of oil for 10 liter, the cost of transportation of oil of 10 liter is rupees 1. Cost of transportation of 10 liters of oil is rupee 1 per kilometer. The cost of transportation of 10 liters of oil is rupees 1 per kilometer. On this idea, oils are transported from the two depots A and B to the pumping stations D, E and F. And what is the minimum cost of transportation using linear programming we have to determine. So pumping depot A has 7,000 liters of oil and depot B is 4,000 liters of oil. The three pumping stations D, E and F are there. From the depot A, X and Y are the liters of oil transported from the depot A to pumping station D, E respectively. X liters of oil from A to the depot D and Y liters of oil is transported from depot A to the pumping station E. Therefore, the remaining 7,000 minus X minus Y liters of oil are transported from the depot A to the pumping station F. If X and Y are the liters of oil transported from the depot A to D and E, the remaining 7,000 minus of X plus Y is transported from A to the pumping station F, that is 7,000 minus X minus Y is the capacity of oil transported from the depot A to the pumping station F. Similarly, Y liters of oil transported from the depot A to the pumping station E. Therefore, the remaining 3,000 minus Y liters of oil is transported from the depot B to the pumping station E. Since Y liters is transported from A, the remaining 3,000 minus Y is transported from B. Similarly, X liters of oil is transported from A to the depot D. From the depot B, 4,500 minus X liters of oil is transported from B because the capacity of the pumping station D is 4,500. 4,500 minus X liters are transported from depot B to the pumping station D. Similarly, 3,000 minus Y liters of oil transported from depot B to the pumping station E. Therefore, the remaining 4,000 minus of 4,500 minus X plus 3,000 minus Y. The oil is transported from the depot B to the pumping station F. The pumping station from the depot B, the oil transported from the pumping station B to the depot B to the pumping station F is 4,500 minus X plus 3,500 minus Y is subtracted from the oil requirement of oil from the depot B. This is 4,000 minus of 4,500 minus X plus 3,000 minus Y. 3,000 minus Y is the oil transported from the depot B to the pumping station F. On simplification, I will get X plus Y minus of, on simplification this step, I will get X plus Y minus of 3,500. So for this problem, the constraints are X greater than or equal to 0, Y greater than or equal to 0. X and Y are non-negative, and 7,000 minus x minus y is greater than or equal to 0. From this I get 7,000 greater than or equal to x plus y, or x plus y is less than or equal to 7,000. You can write this 7,000 minus x minus y is positive. From this I get x plus y less than or equal to 7,500. These are the constraints of the problem 1, and this is equation 2. And similarly 5,000 minus 500 minus 4,500 minus x is greater than or equal to 0. It's again a constraint. This is nothing but x less than or equal to 4,500. X less than or equal to 4,500. This is constraint 3. Similarly, 3,000 minus y is greater than or equal to 0. From this, y is less than or equal to 3,000. This is constraint 4. Finally, the fifth one is x plus y minus 3,500 is greater than or equal to 0. This is x plus y. From this I will get x plus y is greater than or equal to 3,500. This is constraint 5. These are the 5 constraints for this linear programming problem. Using these constraints, we are going to find out the minimum transportation charge. Okay. Well, again, the cost of the transportation is 10 liters. So the cost is, transportation cost is 10 liters. Cost is rupees 1 per kilometer. Therefore, x liters is transported from A to the depot D is x by 10 rupee. Similarly, y transported from the depot A to the pumping station E, therefore the cost is y by 10 rupees. The y liters transported from the depot A to the pumping station E is y by 10. So because cost of transportation of 10 liters is 1 rupee, cost of transportation of 1 liter is 1 by 10 rupee. Therefore, x liter is x by 10 rupee. Like that, you have to find out the constraints equation. And now, using this idea, I am going to draw the graph. So from this idea, using these constraints, the graph is origin, x-axis, y-axis. This is y-axis. X greater than 0 is x equal to 0, y-axis. Y greater than 0 is y equal to 0 is x-axis. The scale along the x-axis is 1000 per centimeter. Unit 1000, 2000, like that. $2,000, $3,000, $4,000, $5,000, $6,000 and $7,000. Similarly here, 1,000, 2000, 3000, 4, 5, 6000 and 7000. So first is x greater than 0 and y greater than 0 is x axis and y axis. Third one, x plus y greater than or equal to 7000 is, if you put x equal to 0, y is 7000. If you put y equal to 0, x is 7000. So if you draw the graph 7000 to 7000, this point x is 0, y is 0, x is 7000. If x is 0, y is 7000. You have to join these two points. So this is a line x plus y equal to 7000. This line is x plus y equal to 7000. Similarly, x less than or equal to 4500 means x equal to 4500. This is 4500, this point. So line x equal to 4500 is line parallel to y axis at 4500. X equal to 4500. This is the line x equal to 4500. Similarly, y less than or equal to 3000 means y equal to 3000. So draw a line at y equal to 3000. This is the line y equal to 3000. And final equation x plus y equal to 3500. If you put x equal to 0, y equal to 3500. X equal to 0, y equal to 3500. And y equal to 0, x equal to 3500. So joining these 2 points, x equal to 3500, y equal to 3500. And this line is x plus y equal to 3500. This is x plus y equal to 7500. X plus y greater than or equal to 3500 means this is the shaded area. The bounded region is this, in between these points. This is the bounded region. Feasible region for this linear programming is (3,500) greater than or equal to 0 is away from the origin, and x plus y is less than or equal to 7000. X plus y equal to 700. 7000 is less than or equal to means towards the origin. This is. So in between these two lines, and x equal to 4500 and y equal to 3000. This is the bounded region for this linear programming problem or feasible region. The corner points of this bounded region are, this is A. The point A is 3500, 0. 3500, 0. This point is B, 4500, y0, and this point C. C is the point C. 4,500, this point 2,500, this is 2,500, C is 2,500, X 2,500, sorry, Y, X is 4,500, 4,500, comma 2,500, sorry. C is X 4,500, Y, this point Y is 2,500. This is the point 2,500. Similarly, D, A, B, C, D. D, X is 4,000, 3,000. D is, this is 4,000, 3,000. A, B, C, D, E. E, the point E is, Y is 3,000, X is 500. 500, 3,000. It is E. These are the corner points. For these corner points, we have to observe that what is the equation? Transportation equation. Cost of the transportation equation we have to determine by adding all these constraints. So, the objective equation from the diagram, the construction saw, from these constraints, the cost of the transportation equation is equal to cost of the transportation equation is equal to X. That is, from the diagram we have seen X is 6x by 10, and similarly Y is from the equation, from the diagram we get X is 6x by 10 and Y is, sorry, this is 7x by 10, because 7 liters distance of A is 7, therefore 7x by 10, this is 6y by 10. 10 is 10 liters per 1 rupee per 10 liters, therefore 7x by 10 plus 6y by 10, and also three into 7,000 minus x, sorry, 3 by 10. From the diagram we have seen 3 by 10 into 7,000 minus x minus y. This is the equation. 7,000, this is x, 6x, 7x by 10, 6y by 10, 3 by 10 times of 7,000 minus x minus y. And fourth one is plus, from the diagram you can see 3 by 10 into 4,500 minus x, 4,500 minus x plus further one 3,000 minus y, that is 4 by 10 4 by 10 into 7,000, sorry, 3,000 minus 4 by 10 into 3,000 minus y plus 2 by 10 into x plus y minus 3,500 from this. So from the table, the objective equation Z is equal to transportation for cost of transportation. From this equation Z equal to, using these constraints, we have found out the equation. On simplifying, you will get Z equal to what is the 3 by 10x? On simplification, you will get 3 by 10x plus 1 by 10y plus 3950. On simplifying this, you will get this equation. Z equal to 3 by 10x plus 1 by y by 10 plus 3950. Usual multiplication, and you find out the x terms and the y terms, you collect all these things, and the constant terms, you simplify, you will get this equation. This is the required equation for finding the transportation cost. From this equation, we have to substitute the corner points, and we will get the minimum value. From this table, corner points A, that is 3500, 0. A equal to 3500, 0. What is B? B is 4500, 0. C 4500, 2500. D 4000, 3000. And finally E 500, 3000. On substituting these value corner points in the value of Z in the equation, Z equal to 3 by 10x plus y by 10 plus 3950. Plus 3950. On substituting, you will get the values are in this equation. If you substitute x equal to 3500 or y equal to 0, the first value is 5000 and the next one is 5300. Substituting this point C, the point is 5550 and D is 5450. If you substitute E, you will get 4400. From this you can say this is the minimum value. The transportation charge is minimum, that is 4400 at 500 liters, 500. X value is 500 and Y value is 3000. On substituting x equal to 500 and y equal to 3000, you will get the minimum cost. So minimum cost of transportation is equal to 4400 rupees. Minimum cost is 4400 rupees at x equal to 500. X liters of oil of cost 500 and y value is 3000. At this point, corner point, we will get the minimum value. So this is the problem. So that's all about the problem. And thereby I conclude this problem. So this is the minimum cost. This is the transportation problem using linear programming. Thank you.